Hello everyone, how are you all? I hope all are doing absolutely great and amazing, and you all are staying at home. And today's discussion topic is basically the part 3 of thermal expansion, and today we'll start also a new topic, that is heat transfer. Okay, so at first we can know the third part of thermal expansion is about the thermal expansion in liquid. We have already know a equation in the last video. We can remember the equation, recall this, that is V final is equals to V naught plus 1 plus gamma delta T. Yeah, everyone can remember this. V final means the final volume is equals to the initial volume into 1 plus gamma delta T. Okay, that we can know. And we also know about a force, that is bind force. Okay, now we're gonna see about the thermal expansion in gases. What you can know this, the thermal expansion is in gases means I will take a balloon. Okay, I will take a balloon. We can know this, that there are lots of molecules of gases, small molecules of gases. Okay, now I will give some heat in it. This is the candle and I will give some heat in it. Then after some time the gases expand. Okay, but you can see that after some time the gases will be expand and the balloon will be burst with dum. Okay, so what you can see this, that after giving the temperature, at first the temperature, that is T naught, that is the initial temperature, and I will give the temperature and the temperature, that is T final. So at the temperature of T final the gases are expand and the balloon of the burst. What you can say, balloon is also expand, but the expansion of gases, okay, I will write here that you can see that the expansion of gas is larger than the expansion of the balloon. Expansion of the balloon. So what you can see, that expansion of the gases is huge, you can say larger than the expansion of the balloon. Means the material in which the gas is in, means in which the gas is in which container the gas is in, the expansion of the container is too smaller than the expansion of the gas. I hope is it clear. Okay, so now we're gonna see about one thing that we can know, that is Charles law. Everyone can know this and also read this in the kinetic theory of gases. Here we can know equation, that is PV is equals to nRT, that is the ideal gas equation. Yeah, okay, so now we're gonna talk about somehow of Charles law. Charles law is given by basically Charles, and what you can say, that we can see this, at the constant pressure, the volume of the gas, the volume of the gas, the volume of the gas. Okay, so now I will take a beaker that are full of gases. At first the temperature of this is T naught. Okay, and then the temperature of this is T. At first the volume of this is V naught, and then the volume of this is Vt. Okay, so we can write that the Vt is equals to V naught into 1 plus T by 273. Okay, so the final equation of Charles' law that we can find that V T is equals to V naught T by 273. And you also, if the final temperature is if the initial, this is initial temperature, that is final temperature Vt, so you can write Vt is equals to V naught by 273 into T. I hope is it clear? That is some basic things of this. So now we can see about the coefficient of thermal expansion is gases, again gases. So what you can say that in the gases expansion we can, what you can say that they have linear expansion, they have area expansion, or they have volumetric expansion. Yes, you are right, they have the volumetric or volume expansion. So we can know that in the volumetric expansion, that you can know that is change in volume by the V naught delta T, and the coefficient of volume expansion is gamma. So you can write that the gamma is equals to V final minus V naught into V naught T. Here the T is the temperature, V naught is the initial volume, here also the V naught is the initial volume, and this is Vf is the final volume. That is, and here also we can say that there have thermal expansion in gases. Okay, so what we can say that in the what is the formula of, we can say that delta V by V is equals to delta V by V is equal delta V by V is equals to 1 by T. I hope is it clear? Okay, so that is the topic of thermal expansion in gases. Now we will be, let's move on to the topic, the first part of heat transfer. Now we can change the heading, that is heat transfer. Okay, here I will take give you some example of this. Okay, here I will take a stick of matches and I will give some heat in it. Okay, when I touch this place, ouch, this is too hot. How you can say I will give only this place of it, but I will touch here, then this is hot, and if I will touch here, this is also hot. From this phenomena and from this demonstration we can tell that the heat can transfer one place to another place. Okay, now there have old type concept which we can only know that is not useful for us. This is only a story. Okay, listen. In the past times, some people know that the calorie, or you can say heat, is a fluid which can travel. I will take a stick which is made of a metal, or any type of conductor in which the heat can travel, and I will give some heat in this place, in this part, and the heat can flow. Okay, heat can flow. So they can say that calorie means heat. Calorie is the unit of heat. So in the first times, calorie is written as heat. The another name of heat is calorie. So now we will not write this. So calorie or heat is a fluid which can travel here to here. So we can feel here as hot. Okay. So now there are the three processes to heat transfer. There are the three processes to heat transfer, that is conduction, convection and radiation. Conduction, radiation. What you can say? Conduction, convection and radiation. In our syllabus we will only read about the conduction. Okay, we will only read about the conduction. Okay, I will make it here and I will give a headline of conduction. Conduction. Okay, in the conduction process there have, okay, imagine I will okay, a teacher of your class, okay, that is a teacher, he will be sitting and there have the blackboard, and teacher tell the students, please give me a pen. A teacher tell the student, imagine this, a teacher tell the students that please give me a pen, I will not take any pen in this class. Okay, so there are three types to give you the pen. They are the students. There are three types. The first type, that if this person has the pen, he will be give this pen into his this, and he will be give this into this, and he will be give him, 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 and he will be give the teacher. That is the first process. Second process, any person or any student go and give the pen, just take the pen. And the third thing, which no, I think you should not do this. Okay, that is, you throw the pen to your teacher. Okay, so you must be not do this. You can do this and you can do also the second type. So first one is where you can give the pen by the students, and he give him, he give him, he give him. This is said to be the conduction. And then if any person will be, any student will be give this pen to his teacher by changing his position, then this is said to be convection. And third one is the radiation. If you can throw the pen to your teacher, then that is radiation. Okay, I hope this is clear. Heat transfer, in this case, heat transfer by the molecules collision. Okay, now what you can say, that I will take a conductor of heat. Okay, here the molecules of the solids, means I will take a metal, okay, piece of metal. When I will give this molecule, the kinetic energy of the molecule is high, so it can give some of its energy and momentum transfer into this, and this also transfer into this, 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 and this. Okay, and this position will be heated. There we can feel the heat. There have the actual flow of matter. If there have actual flow of matter, no. There have flow of the energy and the momentum. The flow of, they have the flow of energy and the momentum. Okay, So if I will give heat in this place, then I also can feel here the heat. Okay, so this process, at first we can write here the temperature of this is T1 and this is T2. T2 is less than T1, means T1 is greater than T2. Okay, so what you can say that this is the conduction, by conduction. Okay, so I hope this by conduction process is clear to all. Okay, now we gonna the two states, that is the variable state and the steady state. Okay, variable state and the steady state. Okay, I will take an example. Wait, and I will do another same demonstration. Okay, so I will take same thing and I will give it heat, and I will touch the every place of this piece of iron or any metal. Okay, I will touch it here, that is too hot. Oh, ouch. And that also less than from this, less than from this, less than from this, less than from this. So according to this demonstration, what you can do, I will write it here, that which phenomena we can see. That this is the conductor of the heat. Here I will give heat that is of 10 degree centigrade, sorry 20 degree centigrade. When the heat can flow, कुछ तो देखो यहाँ पे जो हीट है ये मॉलिक्यूल्स कुछ एब्जॉर्ब कर रहे हैं और कुछ छोड़ रहे हैं, ठीक है, कुछ एब्जॉर्ब कर रहे हैं कुछ छोड़ रहे हैं. यहाँ पे मैंने T1 टेम्परेचर दिया, यहाँ पे आते हुए जो टेम्परेचर होगा T2 हो जाएगा. तो कुछ ये एब्जॉर्ब कर रहे हैं, तो यहाँ का जो टेम्परेचर होगा दिस पॉइंट दैट इज 15, in this point that is 10 degrees Celsius, and in this point that is 5 degrees Celsius. Okay, that is the heat transfer. That is heat transfer. There are 20 degrees Celsius, 15, 10, 5. So for this, when I will touch it, that is too hot, but when I will touch this, this is less than hot of this. This is less hot. Okay, so what you can say, and I will also give it heat. I will give heat continuously. Okay, so that is 40 degrees Celsius. So here that is 35 degrees Celsius, that is 30 degrees Celsius, that is 25 degrees Celsius, that is 20 degrees Celsius, and that is 15 degrees Celsius. That I have to call as the variable state. That is called as variable state. Okay. Yes. The temperature at the point, this point, this is the point, this is the point, this is the point, this is the point, are different. The temperature at a point of the conductor are different. What the way, and I will stay to the steady state, means I will take a conductor and I will give 100 degrees Celsius. There that is the 50 degrees Celsius. Here that is 30 degrees Celsius. I will give it heat continuously in it, but that is also 100 degrees Celsius, that is 50 degrees Celsius, that is 30 degrees Celsius. That have no change, means that is the constant. The heat here, that is constant. That is called steady state. Steady state. That is in our syllabus. The steady state in our syllabus. Okay, that is not, we can read it. I hope is it clear, the steady state and the variable state. Okay, heat flow. Okay, a simple thing that if there have the flow of heat, matlab there have the differential of temperature. Heat flow means there have the different in temperature difference. Okay, so steady state, I will write the temperature of each cross section remain constant with the time, with respect to time. Temperature, okay, remember, temperature of each cross section, this is a cross section, are constant at to the respect of time. This is called as steady state. Now I will draw a picture here. Now I will talk only about the steady state. Okay, so I will give Q. Here also the pass of Q, here also pass Q, here also pass Q. Means जितना टेम्परेचर यहाँ से आ रहा है उतना टेम्परेचर बाहर चला गया. This is called as the steady state. There have some equation of steady state that we will read. The dV, that is dt by, that is not working, dt by dx. The temperature by the length, dt means the temperature by the length is 0, or dt by dt is 0 in with respect to t and with respect to x. X is a variable. Okay, so this cannot be go to 0. This is 0 because the temperature by the jitna temperature, there have no difference of temperature, means the temperature difference is 0. So that is called 0, but that is not be 0 because it is the temperature and that is the length of this. Okay, I hope is it clear. Okay, now in this next video we're gonna discuss about the amount of heat flow through our conductor, how we can calculate this, and there have a equation that is Q is equals to K A T1 minus T2 by L. There have a equation into T means time that we can read in our next part. Okay, I hope the whole concept is clear. If is it clear, then thank you, bye bye, see you, take care of yourself, stay motivated, stay safe, stay at home, bye bye.